Hello everyone, this is Vijay Lakshmi Subnali from WinMaths YouTube channel. Here WinMaths is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and various competitive exams. This channel helps to those who are studying PUC and guide you in making the PUC preparation well for various exams and also have to score more. Now, in this session, we have to continue the last session concept, that is sets. In last video, we already discussed about the sets and method for representation of set based on the methods, that is set builders forms, and another one is the roster forms. We already discussed some example and also writing form of two methods. Now, in this video, we have to discuss or move on the next concept, that is empty set. The concept empty sets. The word empty means it is represents the nothing. In that set, there is no element is present or there is no objects are there. Okay, that type of sets are called as a empty sets. For example, I will take one example. Here, let A be a set containing an element. That element should be X is a student or member. X is a student studying. X is a student studying in a 11th class. Okay, 11th class. Now, the student, I will take any one of the student who is studying in class 11. The number of students in class 11 should be countable or it is finite, because we have to calculate or we have to count the number of students. That time another one student should be the class 11. Okay, here I will consider the another one example. Now X is a member or student studying in a both 10th and 11th class. 11th class. Okay. It is not possible. Okay. Here it is set. Yes, of course. It is set. X is a student studying in a both 11th and 10th and 11th class. Okay. It is of the set builder form. I can write in set builder form. It is correct. But in actual or in reality, the one student both time. Okay, thus one student can't studying in 10th as well as first year or else class 11th on that time. Okay, so it is not a set. Okay, it is called as a empty set. It is not possible when a student studying in both 10th as well as 11th is not possible. Hence, it is a empty set. These type of the sets are called as a empty set. These type of sets are called as empty sets. Okay. Now, we have to define the definition here. Okay. That is a set which does not contain any element is called the empty set, or it can be call it as a null set, or another one word is called as a void set. Okay, these three words are similar. Maybe they call it as a null set, or it may be empty set, or it may be void set. These three names are also similar. Okay, or synonyms of the empty set. Now, let us discuss the example one by one. Okay, here example. Before going to take one examples, here according to the definition of the empty set, according to the definition of set, here I will take the two examples here. Here X is a student studying in class 11th and the set B contain X is student in class 10th as well as 11th. Okay. According to the definition, B is empty set while A is not an empty set. So usually the empty set is denoted by the symbol pi. The empty set is denoted by the pi, or else we can write in a open braces. Okay, we can written in a empty braces. These two symbols represents the empty sets. Now we have to discuss the example one by one. Here let A is equal to x such that the element x which is lies between 1 less than x less than 2 means the element x which is lies between 1 and 2, then x is a natural number. We already know that about the natural number, the number starts with 1, 2, 3, 4, 5 up to so on. But here they given example that a here based on the definition a is not a is a empty set. Here a is empty set because there is no natural number lies between the 1 and 2. This is the example for empty set. Let us move on the second example. Let B be a set such that x square minus 2 is equal to 0. X is a natural number. Okay, now we have to solve this one equation, that is x square minus 2 is equal to 0. While solving the equation, x square is equal to taking minus 2 on right side, it becomes plus 2. X is equal to root 2. We know that root 2 is an irrational number. Okay, root 2 is an irrational number, but here they given x is a rational number. Okay, then B is a empty set because the equation not satisfied for rational number because the value of x is a irrational number. Again, let us move on the next example, that is C. Set C, x is an even prime number greater than 2. We already know that prime numbers. Okay, the prime numbers are the only numbers having a multiplier 1 as well as the own number, that is 2, 3, 5, 7, 11, 13 up to so on. These are the prime numbers. Okay, here x is an even prime number. Here 2 is the only even prime number, but here x is even prime number greater than 2. Greater than 2 means we have not considered the 2. Okay, here C is also empty set. This is also a definite example of the empty set. Next, the example number 4. D is a set containing x such that x square is equal to 4. X is a odd number. Here also while solving the equation, that is x square is equal to 4. We want the values of x are taking as root of 4. It becomes plus or minus 2. X value should be plus 2 or it may be minus 2. 2 is not a odd number. Okay, so this is also empty set. The example shows about the empty set. Now let us move on the next one. That is, let us move on the next concept, finite and infinite set. What do you mean by the finite and infinite? Finite means have to countable. Okay, finite means we have to count, or it has a definite number of elements. Okay, finite means the elements or object should be countable, or else we have to uh, define, or it may be containing a definite number of elements, definite number of elements. Then the sets are called as the definite number of elements. Then the given set is called as a finite if the number of elements are not countable or we don't have the end value. Okay, that is called as a infinite sets. For example, here let us take sets A is equal to 1, 2, 3, 4, 5. And another one set I can take as a B, that is 1, 2, 3, 4, 5, 6 up to so. Okay, up to so. While observing A and B, here in the set A, only the elements are 1, 2, 3, 4, 5. Okay, the number of elements in set A is 5. Okay, definite number we have, and the element should be countable. Then it is said as a finite set. While observing the same set, that is B, here also containing the same number of elements 1, 2, 3, 4, 5, 6. But up to so on means there is no end here. Okay, the element starts from 1. After that 6, the element should be up to so on. There is no end point. That's why it is a indefinite sense. Okay, now based on these example, observe the definition. A set which is empty or consists of a definite number of elements is called finite. Okay, if a set is said to be a finite, then it may be empty set. Okay, it may be empty set or it contain a finite number of elements. Finite number of elements, then the given finite number of elements, then the given sets are called as finite. Otherwise, it is a infinite set. So we can guess another one concept here. Empty set is also a finite set. Okay, empty set should be a finite set. According to the definition of finite set, the set is said to be a finite. It may be empty or it containing a finite number of elements. Now, let us discuss the example one by one. Examples. Let W be the set of the days of week. Okay. Here, let W be the set of the days of the week. We know that days of the week. Okay. How many days of the week? There are 7 days in a week. There are 7 days in a week. So 7 means it is a definite number. 7 means it is the definite and countable. So W be the finite set. Here W be the finite set. Now let us move on the next question. Let S be the set of solutions of the equation x2. Sorry, here it is x square minus 16 is equal to 0. While solving the equation, x squared minus 16 is equal to 0. Then x squared is equal to taking minus 16 on right side, it becomes plus x squared, x is equal to root of 16. The value of x, the solutions of x is plus or minus. Okay, let S be the set of solutions of equation. The solutions of the equation are written in a set form, that is minus 4 and plus 4. We have to count these two numbers. Okay, then the let S be containing only two elements. One is minus 4 and plus 4. Therefore, it is also finite set. The given set is also finite set. Now, let us move on the example number 3. Let G be the set of points on a line. Here I can draw a one line. Okay, here the starting point A and end point B. From this A point to B. GB set of points. Here I can take one point here. I can take here. Take. Okay. Now from A to B, so many points I can draw on that line. Okay. It may be large point or it may be minor point. What? But here there is a set of points. So many points on a line. We can't count the points on that line. Therefore, it is a infinite set. This is a infinite set. Let G be the infinite sets. Okay. Here it is clear. Now let us move on the example. Okay. While solving the example, the concept will be clear for you. Now, example, state which of the following sets are finite or infinite. Okay. Here we can study one by one. Now, x such that x belongs to n and x minus 1, x minus 2 is equal to z. Okay. While solving this equation, the x values are given for us. Okay. Now, x minus 1, x minus 2 is equal to z. Then, x minus 1 is equal to 0 and x minus 2 is equal to 0. While solving this one, x is equal to 1 and x is equal to 2, such that the x is belongs to natural number. We know that the natural number 1 and 2 both are the natural number. Therefore, the first one example is a finite. It is a finite set. Now, let us move on the next one. X such that x belongs to n and x square is equal to 4. Okay. Here I can solve the second one here. That is x square is equal to 4. Now we want the x value. Taking this square on right side, it becomes square root. So we get plus or minus 2. It means it is plus 2 as well as minus 2. Now, here x belongs to natural number. We get the two solution. One is plus 2 and minus 2. The natural number containing only positive number. The natural number containing only positive number starts with 1 only. That's why here the only the one element is. Therefore, it is also finite set. Now, let us move the next one. X such that x belong to n and 2x minus 1 is equal to 0. Now, we can solve the third one problem, that is 2x minus 1 is equal to 0. Next, 2x is equals to taking minus 1 on right side, it becomes plus 1. X should be 1 by 2. Okay. Now, here the value, okay, the value of x belongs to n. 1 by 2 is not belongs to n. Because 1 by 2 is not a natural number, the example 3 should be a empty set. Now, let us move on the question 4. X such that x belong to n and x is a prime number. We know that x is a prime number. The prime number starts with 2. 2. It is also natural number. 3 natural number. 5 natural number. 7, 11, 13 up to so on. These are the prime natural numbers. Now, let us move on the next one. Here x such that x is belong to n and x is an odd number. So we can collect the odd natural numbers, that is 1, 3, 5, 7, 9, 11 up to so. Okay. While observing the 5 example, we have to segregate the sets finite and infinite. Here 1 comma 2 which is countable, it is finite. 2 is also finite. According to the definition, the finite set means it may be a empty set also. So it is also finite. Now, fourth one, the prime numbers 2, 3, 5, 7, 11, 13, up to so on. So we don't have the last end value, hence it is a infinite. Again, the fifth one is the set of odd natural numbers. It is also infinite. It is also infinite. Now the concept is clear for you. Okay. Let us move on the another one important concept, that is equal set. Okay. Equal means have to be a same. Equal means in, for example, I will consider the is equal to the LHS part and RHS are same, exactly similar. That time both are same, then we have to say the equal. Okay, equal means in generally, for example, when we consider two sets, for example A and B, both sets having the same number of elements, that time both sets are equal. Okay, now let us move on the definition of the set. Then I have to consider the two sets. Okay, that is two sets A and B are said to be equal if they have the exactly same elements, and we have to write A is equal to B. Otherwise, the sets are said to be unequal. For example, if A is a set containing the elements 1, 2, 3, and another one set B containing the elements 1, 2, 3, then both sets A and B are equal. Okay, both A and B are equal, then it can be written as A is equal to B. If, for example, A is equal to 1, 2, 3 and B containing another one element 4. Okay, now A and B are not equal because here in the set B another one element is there, that is 4. So both are not equal or unequal, then that time it can be represented as A not equal to B. Okay, now let us discuss the example here. Example. First one, let A be a set and B is also set. Here A containing the elements 1, 2, 3, 4 and B containing the elements 3, 1, 4, 2. While observing A and B, 1 is there, here also 1, 2, 2, 3, 3, 4, 4. Here A set is also containing 4 elements, B set is also containing 4 elements, and those 4 elements are also equal. Therefore, A and B are the equal sets. Now, let us consider the another one example. Let A be the set of prime number less than 6. Let A be the set of the prime numbers less than 6. Okay, now first I can take the set A. The prime numbers less than 6 are 2, 3, 5. Only the 3 elements less than 6. Those are the prime numbers are 2, 3, 5. And another one set P. Set of prime factors of 30. Prime factors of 30 while solving the 30. Here 30. 2 15s are 30. Now 3 5s are again 5 ones. According to the while solving the problem, the prime factors of 30 are 2, 3, 5. While observing the two sets A and P, both having the same elements 2, 3, 5. Here also 2, 3, 5. Therefore, these A and B are the equal set. Okay. Now, here there is a one important note point is there according to the based on this concept. A set does not change if one or more elements of the sets are repeated. For example, set A containing the elements 1, 2, 3 and set B containing the elements 1, 2, 3, comma 3. Now, here there are 3 elements. Here also only 3 elements. 3 and 3. We have to write twice. I can write 3 element as a twice. According to set theory, it is not written like that, but sometime, okay, when they can write 1, 2, 3, comma 3 means here both represents only 1. This time is also it is the equal sets. That is both are equal since each element of A in B as well as vice versa. That's why we generally do not repeat any element in a describing set. Okay. Now let us move on the example. Based on the example, we have to know the concept better. Okay. Here example number 7. Find the pairs of equal sets if any give reason. Okay, here A be a set containing the element 0. Now, another one set B. Okay, here X, the element X is greater than 15 and that element X is less than 5. According to the set, I can write here the value of X. Okay, here the value of X less than 5 as well as the value of X greater than 15. It should be a null set because in between the less than 5 and um, greater than 50 there is no element. Now the next one is x minus 5 is equal to 0. While solving that x taking x minus 5 is equal to 0, then x become 5. Therefore it is set containing the element 5. Next, x such that x square is equal to 25. While solving this, x square is equal to 25, then the element x should be a plus or minus 5. Here x should be plus 5 or else minus 5. Now let us move on the E. Here x is an integer, x is an integral positive root of the equation. While solving this one, x square minus 2x minus 15 is equal to 0. Okay. While solving the quadratic equation, we have to consider minus 15 here. While multiply any two numbers, we get minus 15. Okay. Then those two numbers have to add or subtract, you will get the minus 2. So I will take 5 and 3. 5 3 is a 15. Here I will take minus and this one as a plus. Minus 5 into 3 15. While solving minus 5 plus 3 it becomes 2. So I can take it as x square minus 5x minus plus 3x minus 15 is equal to 0. While grouping only two numbers, we get x minus 5 plus take 3 as a common. X minus 5 is common to both. So I will take separately x plus 3 and x minus 5 while solving the integral positive root. The x value x plus 3 is equal to 0 and x minus 5 is equal to 0. While solving the both, we get x is equal to minus 3 and x is equal to plus 5. Therefore, the roots of the equations are minus 3 and 5. Okay. While observing all the example, while observing the all examples here, okay, according to this one, we have to consider an integral positive root only. Here, minus 3 is the negative root. I will consider only the positive root, that is only 5. Okay. Now, while observing each, okay, while observing each, A is not equal to B, A is not equal to B, and similarly, A is not equal to C, A is not equal to D, and A is not equal to E. Okay. Find the pairs of equal sets. Okay. A is not equal set to any sets. Now, while observing the B. While observing B is an empty set. So A, C, D, E are not a pair of equal sets. Okay. While observing C and E are the only pair of equal sets. C and E are the only equal pairs of sets. Otherwise, there is no equal sets are there. Okay. Now, let's move on the example. Here, while taking this one, E is also not a set. D and E are not a equal sets, and C, D is also not equal sets. Only the pair of equal sets are C and E. Under one last example, which of the following pairs of sets are equal? Which of the following pairs of sets are equal? That is first one example here. Let X be a set containing the letters a lot. Okay. So they given in a set builder form. We have to take in a roster form, or it may be listed here. That is E, L. L is twice, so I can write only once. That is O and Y. The elements of the set X containing A, L, O, Y. And another one set B. The elements of the set B are L, O, Y, A. Okay. Here L I can written once. Now comparing the sets X and B. Here A is there, A is there. L, L. O, O. Y, Y. All the elements of X and B are equal. Therefore, X and B are equal sets. X and B are equal sets. Now, let us move on the second one example. That is, here A be a set containing the elements n such that n belongs to Z, means n be a integer. Okay. And n square is less than or is equal to 4. While solving this, n square is less than or is equal to 4, means n should be, okay, n should be a less than or is equal to, means while taking root on this side, it becomes root 4. N is less than or is equal to plus or minus 2. So, n is less than or is equals to plus or minus 2. Here again, while solving this problem, x belong to a rational number. While solving this one, taking x square minus 3x plus 2 is equal to 2. I have to consider 2. While taking the multiplication, you will get the result 2. Or when you add or subtract, you will get minus 3. So I can take 2 into 1. Here I can take both side minus 1 because minus 2 minus 1 becomes plus 2. Here x square minus 2x minus x plus 2 is equal to 0. While taking grouping, take at x as a common, x minus 2 minus as a common plus as a common, it becomes x minus 2 is equal to 0. While solving this, x plus 1, x minus 2 is equal to 0. Now x plus 1 is equal to 0 and x minus 2 is equal to 0. Again we get the result x is equal to minus 1 and x is equal to plus 2. Therefore, the values are minus 1 and here it containing plus or minus 2. The values are plus 2 and minus 2. While observing the elements A and B, here plus 2 minus 2 is there, here minus 1 plus 2 is there. Both are not same. Okay, the both set containing the different elements. Therefore, A not equal to B. It is an unequal set. It is an unequal set. Up to this much, I have completed the concept, that is empty sets, equal sets and finite as well as infinite set, and also some example. If you have any doubt regarding this concept, please write your doubt in a comment box. I will reply for you. If you really like my channel, please like, share and subscribe to your friends. It may help for those. Okay. Thank you. Thank you watching my channel. Thank you everyone.